Hi everybody! In this video we're going to be talking about rotation symmetry. So if you can open up your symmetry and surface area foldable and open up to the second section called rotation symmetry, that's where you're going to record these notes. And now just so you know, I have made some of the diagrams and notes in advance just to save some time in this video. So you may want to watch it all the way through once and then put it on again just in order to copy out the diagrams and notes in your own time. So you'll probably want to pause the video when you're ready to do that. Okay, so at the very top of this section, you should already have two definitions written: center of rotation and rotation symmetry. So center of rotation, that's just basically the point around which an object or design is rotated. Okay. Now rotation symmetry, so we know that a design or an object has rotation symmetry if when it's turned about its center, it fits into its outline more than once in a complete 360 turn. So if it matches up with itself as you're turning it a full turn around, if it matches up with itself more than just the once where you turn it back, then that means it has rotation symmetry. And obviously we'll look at some examples down here so you can see what I'm talking about a little bit easier. So in our example, it says, find order and angle of rotation. Okay, we're going to talk about what those mean as well. So just sit tight here. So it says, for each shape, what are the order of rotation and the angle of rotation? Express the angle of rotation in both degrees and as a fraction of a revolution. Okay, so now you can see I've got four shapes or designs. A couple of them are more like designs, a couple of them are just shapes. And for each of them, I need to first of all determine the order of rotation, and then I need to express the angle of rotation in both degrees and as a fraction. So I guess the next thing we better do is talk about what those terms mean. So order of rotation is the number of times a shape or design fits into itself in one complete turn. So basically, if the order of rotation in a design or shape is greater than 1, then that's how we know it has rotation symmetry, because that means that it's fitting into itself as we're turning it more than just the one time of turning it all the way back to the starting position. So I'll show you what I mean by that in a moment, but now before we do that, actually no, I'm going to just show you now. So let's stop there and just focus on order of rotation for right now. So in order to determine the order of rotation of a shape or design, what you want to do is take some kind of thin paper or tracing paper, or what I'm using is actually like a parchment paper from the kitchen. Tissue paper, gift wrapping tissue paper also works really well. But even like a thin lined paper, it really does the job pretty well. So in order to determine my order of rotation, or in other words, the number of times this shape will fit into itself in one complete turn, I want to trace it through my tracing paper, or parchment paper in this case. Put my center of rotation in the middle there, and I'm just going to mark my starting point at the very top here. So I know once I get back to the top like this that I've done one complete 360-degree turn. So I'm going to start turning. Put this in the middle here so you can really see. Start turning, and I'm not going to stop until I see it match up with itself. So it's not matching up, not matching up, not matching up, and matches up. So there's one match in a turn, and we haven't finished the turn yet because this line needs to go back to the top. So that's one match. Keep turning, and two. So it matched up with itself twice in a single revolution, in a single 360-degree turn. So that means for A, this little flag shape, my order of rotation, which I have in one of the columns of my table down here, the order of rotation for that is therefore 2. Okay, it matched up with itself twice in a single turn. So I'll show you that again. So I just traced it through, set my starting point upwards, so I always know I want to get that back facing upwards, and I just start turning until the shape is matching up with itself. So you can see it's not there yet, and it matches. That's one. I haven't done a complete turn yet though, so I keep turning until I see it match up again, and 2. So order of rotation is 2. So right away, does that mean it has rotational symmetry? Well, yes. As soon as you see that you have an order of rotation anything greater than 1, then it's a yes. Okay, if you only have, if the only time it matches up with itself is when it gets back to the starting position, then that means it doesn't have rotation symmetry. So then we would say no. So in this case, it matched up with itself twice in the complete turn, so yes, it has rotation symmetry. So let's take a look at this next one here. So again, just going to put my parchment paper over top, carefully trace through my little shape, put a center point, my center of rotation, and then mark my starting point. So I always like to just mark up, then I know once that line is back up, I've done a complete turn. So start turning. One match. Keep turning. 2 matches. Keep turning. 3 matches. 4, and back to start, 5. So it matched up with itself 5 times. I just want to double check that, make sure. So turn, 1, 2, 3, 4, and 5, back to start. And you do count you do count the turn when you get back to start, the match up when you get back to start as well. So that's how I ended up for B with an order of rotation of 5. So does it have rotational symmetry? Well, that's more than 1, so yes. So we can even add to our little definition of rotation symmetry. I know you already have something written there, but you can just put a little star underneath and say if it has an order of rotation greater than 1. Okay, so let's go on to the next one. I just need a little more parchment paper here. Next one, C. So just carefully trace through my little design here. And then mark my starting position line. So once this is facing up again, I know that I'm back to start. So here we go, start turning. Wait until I see the design match up with itself. And 1. Keep going. And 2. Keep going. 3. Almost back to start. 4. So my rotation symmetry there was 4. Matched up with itself 4 times, including the back to start. That you do include that. 1, 2, 3, back to start, 4. So order of rotation for C is 4. So does it have rotation symmetry? That's greater than 1. So yes. Okay. One more piece of parchment paper here. Put it over top of D. And let's carefully trace it through. Put my center of rotation and my upwards facing line so I know when I'm back to start, and begin. Nothing, 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 nothing. I mean, it's, whoops, I can't even see what I'm doing. Sorry, guys. Show you again. So my starting point up there. Start turning. You can see it's not matching up, not matching up. Okay, when I get to this point, it's sort of close. I'd have to adjust this here. That doesn't work, and if I move this over here, it still doesn't quite work because we've got this longer tip on this kite type shape right here that's not matching up with the smaller one on the other end. So it's just not quite a match there. So that means I would just keep turning, go right past that. It's not quite a match, so I can't count it. It has to match up perfectly. And then I'm back to the start. So that was a full turn, only 1 matchup. So order of rotation is 1. So therefore, does it have rotational symmetry? Does it match up with itself more than once in a complete turn? No, it doesn't. It does not have rotational symmetry. Okay, so now that takes care of order of rotation. Angle of rotation, we are going to be using our order of rotation. So let me explain what that means. Okay. So angle of rotation is the angle needed to turn a shape or design into itself. The angle needed to turn a shape or design until it matches up with itself. So how many degrees did I have to turn it before it matched up with itself? So that last one, I had to turn it a full turn before it matched up with itself. So that's an easy one. That's 360 degrees that I had to turn it before it matched up. Okay, so the other ones where I had more matches is a little bit more complicated, but not much. Okay, all you have to do to calculate the angle of rotation is you just take the number of degrees in a full turn, which we all know is 360 degrees. And then you just simply divide 360 by the order of rotation. And that'll give you your angle of rotation in degrees. Okay, however, like it says right here, it says to express it as degrees and as a fraction. So you'll often be asked to do both. And the way that we express it as a fraction is always 1 for 1 turn over the order of rotation. And that's how you express your fraction. That's it. So basically, when we do that, what we're doing is we're stating the fraction of a turn that had to take place before it matched up. So this is the degrees that you had to turn before it matched up. This is the fraction of the overall turn that you had to turn it to before it matched up. So again, let's take a look at the examples so that becomes a bit clearer. So I'm going to need my little tracings again here. So remember this first one? Let's see, how many degrees did we turn it before it matched up the first time? Well, we turned it a half of a turn. There's our fraction right there. And half of 360 is 180. So that actually takes care of A, just like that. So in other words, what I did here is this little formula right here. So a complete turn, in a complete turn, I have 360 degrees. Okay, hopefully you can see that okay. And I just divide that by the order of rotation. So 2 matched up with itself twice in 1 turn. So my degree of rotation comes out as at 180. I turned it 180 degrees before it matched up the first time. Then another 180 degrees to get back to start. Fraction is always 1 in the numerator because we're talking about 1 turn, and then over the order of rotation. So again, that was 2. Or in other words, I had to turn the shape half of a full turn before it matched up the first time. Then I turned it the other half to get back to start. So let's take a look at the next one. I'm just going to use the formulas this time because I already did all of the order of rotations. So just take the number of degrees in a complete turn, 360, and divide it by my order of rotation. So 360 divided by 5. Just pulling out my calculator. 360 divided by 5, 72 degrees. So each time that I turned that pentagon, it was 72 degrees before it matched up. So that was 72 degrees, 72 degrees, 72 degrees, 72 degrees, 72 degrees back to start. Every turn was 72 degrees of my complete circle. So now for fraction, always 1 in the numerator. Denominator is the order of rotation. So I turned it a fifth of the overall turn before it matched up. Okay, C, next one. Same thing, angle of rotation in degrees. I do 360, a complete turn, and divide it by the order. So this one matched up with itself 4 times in a complete turn. So 360 divided by 4. If you need to put it in your calculator, you go ahead and do that. Works out to 90 degrees. So every time I had to turn this 90 degrees before it matched up. So 90 degrees, a right angle, matched up. 90 degrees, it matched up. 90 degrees, 90 degrees. Okay, for my fraction of a turn, 1 in the numerator, as always, over order of rotation, which in this case was 4. So I turned it a quarter of the entire turn each time to get a match with itself. Okay, and then finally, the last one. I already talked about this one a little while ago. I said that this one is actually really easy, but just to show you that the formula still works for even something like this that doesn't have rotational symmetry, 360 degrees divided by order of rotation. Well, what happens to anything divided by 1? It stays the same. So order of rotation, 360 degrees. It took a complete turn before it matched up with itself. So then fraction, we can still use this same formula. 1, always in the numerator. Order, 1. 1 over 1, you'd never see a fraction like that. It needs to be simplified. So how would that look? Well, 1 over 1, that would just simply divide out to 1. So this is half a turn, 1/5 of a turn, a quarter of a turn, and this is just simply 1 turn. Okay, so like I said, I would now recommend going back and just taking your time, sketching out your diagrams, and filling in your notes, filling in your chart. But that is it for rotation symmetry. That's really all you need to know. So really, it's not actually that hard. It's not that complicated. It's just a matter of making sure that you really study these terms and remember what they mean. That's kind of the main thing. And remembering these little formulas here. So anyways, guys, that's it for this video. Thank you so much for watching, and I'll see you in the next one. Bye.